Aura Components Basics. Input data using forms. Learning objectives. After completing this unit, you'll be able to create a form to display current values and accept new user input, read values from form elements, validate user input and display error messages for invalid input, and refactor code from a component's controller to its helper. Input data using forms. As of this unit, we're done with Hello Whatever style components. From here, we'll be creating and assembling the expenses tracker mini app that we've previewed earlier. We'll spend the majority of this unit building and understanding the form that lets you create a new expense, the expenses app container. But before we get started with that, let's also be done with creating plain or downright ugly components. The first thing we'll do then is pull in the Salesforce Lightning Design System, or SLDS, and activate it in our app. The way we'll do this lets us talk a little more about app containers. Note, we're not actually going to discuss SLDS itself in this unit or anywhere in the rest of this module. We're going to focus on getting it added to an app, and then within our example code, we'll use the SLDS classes, but not explain them in detail. See resources for lots of different ways to learn more about SLDS. Today, SLDS is automatically available to your components when they run inside Lightning Experience or the Salesforce app. We sometimes call this running in the one.app container. This built-in version is the same that's used by many of the standard Lightning components. However, SLDS is not available by default in a standalone app or when you use your components, and Lightning Out or Lightning Components for Visualforce. These are different app containers and they provide different services and resources. We'd like to create our own app in such a way that it works and looks good in all these contexts. And fortunately, it's not actually that hard to do. The way we'll do it is by adding SLDS to our harness application. Then, inside the Real Expenses app, really the top level component and its child components, we can use SLDS tools and techniques without worrying about where the SLDS resources, style sheets, icons, and so on come from. That is to say, our app container, the harness app, sets up resources inside its context so that any app running inside the container has the resources it needs. Let's convert those wordy concepts to some code. Create a new expenses app.app Lightning application with the following markup. Here's what's going on. The extends equals force :SLDS attribute activates SLDS in this app by including the same Lightning Design System styles provided by Lightning Experience and the Salesforce app. But note that this harness app is just a wrapper, a shell. The real app is the expenses component, which we haven't created. That's the commented out C:expenses part. It's commented out because we can't save our app until the expenses component is actually created. By way of the wrapper app, our components use the extends equals force :SLDS mechanism to get access to SLDS when they run from this application. When they run inside Lightning Experience or the Salesforce app, with no code changes, they use that container's automatic inclusion of SLDS. In this case, that amounts to the same thing. But this concept of using the outer harness app to set up a context so that the real app doesn't need to worry about context differences isn't limited to style resources. You can use this to provide replacement event handlers, for example, although that's getting ahead of ourselves. Let's learn to walk before we try to fly. The expenses app component. The next step is to create the component that's the top level of our expenses app. Remember, even though we call it an app, it's really just another Lightning component. In the developer console, create a new Aura component named expenses and replace the default markup with the following. What we're creating here is the page header using the grid layout provided by the Lightning:layout and Lightning:layout components. Size equals 6 creates a div container that's 50% the total width, or size 6 of 12. As you might have noticed, components in the Lightning namespace resemble components in Lightning Experience and the Salesforce app. Beyond buttons and layouts, you'll find many other useful components in this namespace that work seamlessly with SLDS styling out of the box. Notice the Lightning:"icon tag? This component renders your favorite SLDS icons in a snap. Gone are the days when you had to create a helper component for displaying SLDS icons. Now you can uncomment the C:"expenses tag in the actual .app and open a preview of what is now just an empty shell. You should see something like the following. Not a lot going on yet, but it's kind of exciting to see the SLDS styling already having an effect. Remember that we're not going to explain most of the SLDS markup, but we'll include some comments in the markup. You can see how we created the header for the app and start to get the idea. The new expenses form. Before we start on the form, let's just acknowledge something up front. What we're about to do is temporary. Remember all that talk about decomposing your app down into separate smaller components and then building it up from there? We're not doing that here, not yet, and frankly, it's a bit of a cheat. But it's a cheat in service to keeping the code from getting too complicated too quickly. We're doing this in a way so we can focus on one lesson at a time, and this isn't a bad way for you to work on things yourself. Build inside one component until it gets too busy, and then refactor and decompose it into smaller subcomponents, as long as you remember to refactor. Okay, preaching. In expenses component, replace the commented expense form goes here comment with the following code for the add expense form. That looks like a lot of code to grasp at once. It's not. When you strip away the SLDS markup and classes, this boils down to a series of input fields and a button for a form submission. Here's the resulting form. Note, Lightning:"input" is the Swiss Army knife for all input fields that's infused with the goodness of SLDS styling. Use it whenever you find yourself reaching for the UI:"input component variety like UI:"input text, UI:"input number, and others. Components in the UI namespace don't come with SLDS styling and are considered to be legacy components. First, notice that we're creating multiple instances of the Lightning:"input component with specific data types. That is, you're not surprised that you'd want to use type equals date with a date field, and so on. There's a range of different types, well beyond the one specified, and it's always best to match the component type to the data type. If you don't specify a type, it defaults to text. The reason might not be obvious yet, but it will be when you try this app out on the phone. Type-specific components can provide input widgets best suited to the form factor. For example, the date picker is optimized for mouse or fingertip, depending on where you access it. Next, notice that each input component has a label set on it, and that the label text is automatically displayed to the input field. There are a few other attributes we haven't seen before: required, placeholder, type, min, and step. Most of these attributes are similar to their HTML counterparts. For example, min specifies the minimum value for the input. If you can't guess what these are for, you can look them up in the Lightning component library, and we'll come back to that deceptive required. Next, there's an aura:"id attribute set on each tag. What's that for? It sets a locally unique ID on each tag it's added to, and that ID is how you'll read values out of the form fields. The fields all share the same ID in this example so that we can access them as an array for field validation. We'll look at how to do that very shortly. Attributes for Salesforce objects, S-objects. But first we'll need to look at the value attribute. Each tag has a value on it, set to an expression. For example, open curly bracket, bang, v.newexpense.amount:_c, close curly brackets. From the format of the expression, you should be able to deduce a few things. V means this is a property of the view value provider. That means that this is an attribute on the component, which we haven't created yet. Based on the dot notation, you can tell that new expense is some kind of structured data type. That is, new expense itself has properties or fields. From the $_c that's at the end of most of the property names, you can guess that these map back to custom fields, most likely on the expense custom object. So new expense is probably an expense object. Cool, we haven't discussed this yet. Here's the actual attribute definition, which you should add to the top of the component right after the opening aura:"component tag. What's going on here is actually pretty simple. The name attribute you already know, and the type is, unsurprisingly, the API name of our custom object. So far, so good. The default attribute isn't new, but the format of its value is. But it shouldn't be too hard to grasp. It's a JSON representation of an S object specifying the type of the object, again, the API name, and values for each of the fields to set it on by default. In this case, we're basically setting everything to a representation of an empty value. And that's, well, most of what you need to know about S objects. From here out, the Lightning Components framework will let you treat new expense in JavaScript and in markup like it's a record from Salesforce, even though we're not yet loading it from Salesforce. Handle form submission in an action controller. So we have a form. Right now, if you fill it out and click the button to create a new expense, what happens? Unless you've run ahead and created it already, you'll get another error about missing controller action. This is because neither the controller nor the action handler specified on the Lightning: button have been created. In the developer console, click the controller button for the expenses component to create the controller resource. Then replace the default code with the following. Okay, this is all new, so let's look at it carefully. First, let's note that this action handler function is basically divided into three sections or steps. Number one, setup. Number two, process form values. Number three, if there are no errors, do something. This structure might be familiar to you because it's a pretty fundamental way to process user input in a web application. Let's look at each of the steps to see how they work in the Lightning component. For setup, all we do is initialize the state of our error checking. It's a simple flag. Is this a valid expense? Each time the click create action handler is called, we'll start on the assumption that the expense data is okay, and then invalidate it if we find a problem. Here's a rundown of the valid expense flag with an initial value that's set to true. Component.find expense form gets a reference to the array of Lightning : input fields that require validation. If the ID is unique, the reference returns the component. In this case, the ID is not unique and the reference returns an array of components. The JavaScript reduce method reduces the array to a single value that's captured by valid so far, which remains true until it finds an invalid field, changing valid so far to false. An invalid field can be a required field that's empty, a field that has a number lower than a specified minimum number, among many others. Input cmp.getv.validity.valid returns the validity of the current input field in the array. Input cmp.showHelpMessage if invalid displays an error message for invalid fields. Lightning : input provides default error messages that can be customized by attributes like message when range underflow, which you've seen in the expense form example. Let's get into some interesting details. Back in Hello Message Interactive, we didn't use find to figure out the label text of the button that was clicked. This is because we didn't need to. We were able to get a reference to that button directly by pulling it out of the event parameter using event.getSource. You don't always have that luxury. Indeed, it's rare when everything you need from user input comes only from the event. So when your controller needs a way to get to a child component, first set an aura:_ID on that component and markup, and then use component.findTheID to get a reference to the component at runtime. Note, component.find only lets you access direct child components. It isn't a magic way to go wandering around the component hierarchy and read or change things. Remember, components are supposed to be self-contained or to communicate with, well, we'll get to that. Validation with Lightning : input harnesses the power of the underlying HTML input element to process form values so you don't have to in most cases. Need to validate a telephone number? Use type = TEL and define the pattern attribute using a regular expression. Need to validate a percentage value? Use type = number with formatter =%. Need to validate something else? Let Lightning : input do the heavy lifting for you. It's when validation fails that things get interesting again. When the user enters invalid input, we want two things to happen. Don't try to create the expense. And number two, show a helpful error message. First, we set the valid expense flag to false when the field validity referenced by input.getv.validity.valid evaluates to false. For the second, we make use of the built-in validation errors or provide custom messages for the errors. In the expense form, the required name field displays complete this field if the field is empty and you try to submit the form. But you can provide your own custom message by specifying message when value missing equals did you forget me. By contrast, if the field passes validation, the valid expense flag evaluates to true and no errors are displayed. And with that, we're on to step 3 in handling the form submission, actually creating the expense. As you can see, to prepare for that, we're getting the complete new expense object from the component attribute, component.getv.newExpense. This gives us a single variable that we can use to create a new expense record. Before we get to that though, here's a question for you to think about. Why don't we pull the form values out of new expense? Get the structured variable once at the start of the action handler and then just access its properties instead of what could be a long series of find.get calls. The reason is simple, because we need references to the individual fields to be able to call showHelpMessage if invalid on them. It's also a good practice to validate the raw form data. Your validation logic doesn't know what kinds of processing might happen within the new expense object. Create the new expense. Remember earlier we said that putting the expense form in the main component was a bit of a cheat? Well, this next section doesn't get the A-bit qualifier. What we're doing here is just flat out avoiding the complexity of really creating the record, and we're avoiding it now because that's the entire next unit. So let's wrap this one up with something simple, but which still shows us some important concepts. First, let's create a place to store new expenses. We'll simply create a local-only array of expenses to hold them. At the top of expenses component markup, right before the new expense attribute, add a new expense attribute, which will hold an array of expense objects. All we need to do is update the expenses array, which, it turns out, is easy in the cheater version of our form, and illustrates yet another important concept. In our controller, we've hidden the work of actually creating the new expense behind this function call, helper.createExpense, component, comma, new expense. In software development, another word for hiding is abstraction, and we're using something called a helper to abstract away our cheating. We've discussed helpers briefly earlier, and we're not going to cover advanced details of helpers in this module. For now, let's say 3 things about helpers. A component's helper is the appropriate place to put code to be shared between several different action handlers. A component's helper is a great place to put complex processing details so that the logic of your action handlers remains clear and streamlined. Helper functions can have any function signature. That is, they're not constrained the way that action handlers and the controller are. Why is this? Because you are calling the helper function directly from your code. By contrast, the framework calls action handlers via the framework runtime. It's a convention and recommended practice to always provide the components as the first parameter to help functions. Okay, let's get on with it. In the developer console, click the helper button for the expenses component to create the associated helper resource, and then replace the example code with the following. For the moment, ignore the disgusting hack part. The other 3 lines of code illustrate a common pattern we've seen before, and which you'll use over and over. Get, process, set. First, we get the array of expenses from the expenses attribute. Then, we add the new expense record to it. Then, we update or set the expenses attribute with the changed array. The reference is not the collection. What's new here is that for the first time, we're updating a collection, an array. And if you're an experienced programmer, you're probably wondering, why do I need the set here? That is, component.get v.expenses gets a reference to the array stored in the component attribute. Component.set vExpenses, the expenses, simply sets the component attribute to the same reference. Sure, in between, the contents of the array has been added to, but the container is the same. The reference to the array hasn't actually changed, so why update it? If you're having trouble understanding what this means, add 2 logging statements before and after the critical statements, and dump the contents of the expenses to the console. Reload and run the app. Add at least 2 expenses and look at the structure of the expenses. Now comment out the component.set line and do it again. What the? Component.set doesn't affect the expenses at all. But, what does it actually do? You are absolutely correct to be asking this question, and the answer is magic. What component.set does here isn't update the value of the expenses attribute. It triggers notification that the expenses attribute has changed. The effect is that anywhere in your app that you've referenced the expenses attribute in an expression, the value of that expression is updated, and that update cascades everywhere the expenses attribute was used, and they all update to re-render based on the new contents. This all happens behind the scenes, handled by the Lightning Components framework as part of the auto wiring that happens when you use open curly bracket, bang v.expenses, close curly bracket. In a word, magic. To summarize, if this were plain JavaScript, you wouldn't need the component.set. In order to trigger underlying effects built into the Aura Components programming model, you do. If you ever write some controller or helper code, test it. If nothing happens, make sure you've done the required component.set. The disgusting hack works around a similar issue with references. To see the issue, change the line to remove the 2 JSON calls and test the app. You'll see what the problem is quickly enough. We'll remove it in the next unit, and so won't explain further. Display the list of expenses. So for all the talk about magically updating anything that uses open curly bracket, bang v.expenses, close curly bracket, guess what? Nothing else is using it yet. Let's fix that. In the developer console, create a new Aura component named expenses item and replace the default markup with the following. If you already created expense item, just update the markup. You've seen the expressions that access fields on the expense record before. This version includes SLDS markup to make it more stylish, also using the open curly bracket, bang v.expense, dot reimbursed _c space question mark space SLDS dash theme double dash success space colon space blank. Expression sets the color green on the container when the expense has been reimbursed. Next, create a client-side controller expense item controller.js with the following code. Here we are converting the date that's returned by the server later to a JavaScript date object so that it's displayed correctly by lightning : formatted datetime and lightning : relative datetime. This conversion is handled during component initialization captured by the aura : handler tag. This is a useful way to handle the initialization event, and we'll use this again later when we load data from Salesforce. In the developer console, create an aura component named expenses list and replace the default markup with the following. There's not a lot new for you here. This is a component that displays a list of expenses. It has one attribute, expenses, which is an array of expenses, expense _c objects. It uses an aura : iteration, and it uses an aura : iteration to create an c : expense item for each of those expense objects. The overall effect is, as we noted, to display a list of expenses. So far, so good. Now add the expense list component to the end of the expenses component. Add it right before the ending /aura : component tag and expenses.cmp. If you reload the application, you'll see an expenses section below the form. It's not quite right visually, but it's good enough for now. What did we just do? We added the expenses list component to and passed the main expenses attribute into it. So now the instance of expenses that expenses list has is the same as the instance of expenses that the expenses component has. They are references to the same array of records, and through the magic of Lightning components, when the main expenses array is updated, the expenses list component will notice and re-render its list. Give it a whirl. Whew, that was a long unit, and it calls for a stretch break. Please do get up and walk around for a few minutes, then come back and we'll show you how to save your